Hey there, I'm Murray, one of the outside sales professionals here at Gregg Distributors. Have you ever gone to look for a new MIG wire or stick electrode only to be bombarded by the never-ending types and variations? Well, worry no more, because in this series we're going to chip off the slag on exactly what you need to know when picking up a welding consumable. So pull down your visor and get some gloves on. It's going to be electrified. All welding processes tend to have the same general setup for creating enough electricity to melt metal. A welding machine is hooked up to a power source which feeds the handheld equipment used to do the actual welding. A grounding lead clamped to the welding surface is then returned back to the welding machine, creating a circuit. This current then forms an electric arc that is so hot it turns the joining workpieces into a pool of molten metal. Finally, a filler metal is melted into the pool, strengthening the joint and creating the weld itself. Now, there will be some variation in the setups between the different processes, but they all achieve the same goal of strengthening and creating structures. First up is shielded metal arc welding, or SMAW, commonly referred to as stick welding. It's been around for a very long time and is one of the most inexpensive forms of welding to get into. It works by sending the current from the creatively named electrode holder down the electrode stick consumable, and when touched to the workpiece, creates the arc, melts the material, and acts as the filler metal in the weld. Next, we have gas tungsten arc welding, or GTAW, also called TIG welding in the industry. This process uses a torch that has a small piece of tungsten in it that carries the arc to the workpiece. But unlike a stick electrode, the tungsten does not become a part of the weld. Instead, a cut length or rod is inserted into the molten weld pool as the filler metal. Protecting the welding process from any outside contaminants is a gas, like argon, that is sent through the torch and over the weld. Even though TIG welding is more complicated and a bit slower due to its two-handed nature, many industries prefer it as it results in much cleaner welds. Finally, we have gas metal arc welding, or GMAW, and is commonly called MIG welding. This process will also use a shielding gas to protect the weld, but instead of a torch in one hand and a rod in the other, it uses a MIG gun that feeds the spool of wire. The wire is then fed through a contact tip, transferring the current to the wire, creating the arc, melting the workpiece, all while acting as the filler metal. The wire will either be fed from the welding machine itself, a wire spool MIG gun, or a wire feeder box that is connected between the welding machine and the MIG gun. This process can be much faster than TIG welding, and it's generally the easiest to learn. There are two other processes that fall under the GMAW umbrella, as both use wire feeding. First, there is GMAWC, which stands for Gas Metal Arc Welding Cored. In this process, instead of using a solid wire, it has a tubular wire that contains a metal powder inside. That metal powder helps increase the weld deposition rate, or the speed of the weld. Then we have FCAW, which stands for Flux Cored Arc Welding. This process also uses a tubular wire, but instead of a metal powder, the wire is filled with a material called flux. This flux turns into a solid coating called slag on top of the weld, keeping the molten weld pool in the joint as it cools. as well as protecting it from oxidization and the environment. Flux Cored Arc Welding itself has two different types. FCAW stands for Flux Cored Arc Welding Gas Shielded, which simply means that, like GMAW, gas is required to protect the weld. FCAWS, on the other hand, stands for Flux Cored Arc Welding Self-Shielded. In this process, the flux alone protects the weld from the environment. No gas is required. In industries that do outdoor welding, this is a huge advantage as they no longer need to lug around bottles of gas. And they don't need to worry about wind blowing the gas away, which in turn negatively affects the weld. There are many other types of welding out there, from submerged arc welding to laser beam welding and even atomic hydrogen welding. But the processes we will cover in this series are the main types that you will encounter on a day-to-day basis. Now, one thing that all these different processes have in common is that they all use consumables. Welding consumables are the filler metals used in the welding process. So this covers stick electrode for SMAW, cut lengths for GTAW, and wire spools for GMAW. It is very important that the correct consumable is used for the correct job. Otherwise, the weld could be compromised and not meet its structural requirements. Thankfully, the American Welding Society, or AWS, has created standardized classifications that all welding consumable manufacturers follow. So whether you use Lincoln, Miller, ESAB, Hobart, or any other options on the market, you'll know that they're all made with the same specifications. All right, I think that's enough information for now. On the next episode of Gear Up with Greggs, we will cover the AWS classes for stick welding and, more specifically, break them down so that you know how to read them. If you can't wait or you need help with any of your other welding needs, give us a call or stop by one of our Western Canadian locations. Thanks for tuning in to Gear Up with Greggs. Have a great Canadian day.